Assalamualaikum and hello. Hello to all and Dr. Shima. Today, our group 7 will present determining the best dose of vaccine to induce shoot growth of durian for test 2 agriculture biometry. And the group members are Muhammad Haiqal Nazrin, Adly Haqeem, Shevana Kaur, Sarvesh, Kumar, and also Khadijah. Before that, I would like to share on our role in this assignment. So Haiqal is the statistician, Sarvesh is the slide designer, Shevana is the reporter, and Khadijah is the designer, and me, Adly, as the presenter. So this is the data for the question that we get for this assignment. So the question goes as: to improve the protocol of grafting of durian, a researcher needs to determine the best dose of auxin to induce shoot growth. 3 doses were sprayed each day for a week, respectively, onto the cuttings and shoot length. Was measured in millimeter after 14 days. The treatments were replicated in 4 different incubation chambers. And if the treatment is significant, it has to compare through 2 key HSD. And this is the data for this question. This is a table of content that we will go through. So the first one is the objective, and then the hypothesis, the factor, the level, the variable, experimental unit, replication, sampling unit, data analysis, syntax for ANOVA, result of ANOVA and post-ANOVA, and lastly is the result interpretation. So the objective of this experiment is to determine the best dose of auxin to induce shoot growth. And then the hypothesis for the treatment. And there is 2 hypotheses because the design we use is RCBD, random complete lot design. So there will be 2 hypotheses. So the first hypothesis for treatment, the null hypothesis is there is no significant difference on the shoot growth between different doses of vaccine. And the alternative hypothesis is there is significant difference on the shoot growth between different doses of vaccine. And for the block hypothesis, the null hypothesis is there is no significant difference on the shoot growth between different incubator chambers. Then the alternative hypothesis is there is a significant difference on the shoot growth between different incubation chambers. Now we move on to the factors. So the factors that are used in this experiment is the dose of vaccine. And the level of treatment is there are 3 level of treatment. First level is 0.1 gram per ml. The second one is 0.5 gram per ml. The last one is 1.0 gram per ml. There is 2 variables for the experiment. First, the independent variable, which is the dose of auxin, which we can manipulate. And the second one is the dependent variable, which is the length of shoots. The experimental unit for this experiment is the cutting of durian tree. And this is the design that we use, the random complete block design. So you can see that we arrange in 4 blocks, where each block have all 3 treatments with different level of treatment. And the sampling unit will be the durian tree. So now we go to the data analysis for this experiment. So this is the analysis that we use Excel. For Excel, so we use ANOVA in Excel. So you can see that the value of F critical is that there's just the analysis for Excel, and then we go to the data analysis through the RStudio. So this is the table of data from the question. So we transfer into RStudio, and then this is the syntax for the RStudio. This is a continuation of the syntax for ANOVA and post ANOVA in RStudio. And so from the analysis that we ran through Excel and also R, we can conclude that the F calculated for treatment and block is greater than F table. Thus, we reject the null hypothesis, the HO. There is significant difference between different oxin and also between incubation chambers towards the shoot length of durian. And since there is significant difference between block, therefore this RCB design is efficient for this experiment. And lastly, the oxin dose at 0.1 gram per ml, treatment 1 gives the highest mean of shoot length, therefore treatment 1 is the most efficient oxin dose among other two. So this is the graphic representation of this experiment. And that's all from us for today. Thank you very much.